I am going to present about relation between the tensile property. First of all, introduction to the tensile property. Tensile property describes how material behaves when subjected to the axial pulling force. In a tensile based test, a pulling force is applied to the specimen to measure its behavior fracture. These properties are determined using a tensile test performed in a universal testing machine. The tensile test is tested by the UTM machine. The tensile test provides a stress strain curve which gives complete mechanical behavior of a material. The stress strain curve presented the mechanical behavior of the material when applied load. The stress strain curve applicable in the structural designing, material sections, quality control and safety evaluations. Stress strain curve basics and curves. Stress, applied force and original cross sectional area. What is meant by stress? Stress is nothing but when external force is applied to the material to develop the internal resistance is the tensile material. Strain, change in length by original length. Strain is nothing but the deformation procedure is a material due to the applied stress in that how much change their length of the specimen by the stress. Stress and curves, stress and strain helps identify the elastic and plastic behavior. Stress and curve consists of propagation limit. Stress is directly proportional to the strain. Elastic limit. In the elastic limit, before yield point is considered as an elastic limit. In elastic limit, the elastic limit load is applied to the material. It is elongated when the material is come to original shape or a size. Yield point. After that yield point, the material behaves like a plastic deformation. That means permanent deformation. When the load is removed, it does not come to the original position. UTS, universal ultimate tensile strength. In the UTS, the material is starting form like a necking by the load. Necking region, localized reduction in area. Before the fracture, by the elongation, the neck will be formed. Fracture final breaking of the specimen. Relationship between the yield strength and UTS. Yield strength, a stress at which plastic deformation begins. UTS, maximum stress. For the ductile material, after yield, the material undergoes a strain hardening which increases stress until reach UTS. In the ductile material, after the yielding point, strain hardening will be occurred in the material that increase the stress up to the UTS point in the ductile material. Strength ratio by the yield strength divided by the UTS. For mild steel 0.6 to 0.7. For high strength steel 0.8 to 0.9. Strength versus ductility. Strength means the load is applied to the material in that how much they resist the deformation, that is a strength. Ductility means is the elongation of the material by load before fracture. Increase in strength, decrease in ductility. This is the strength ductile trade-off. For reason why the strength increase, the ductility will be decreased. First, increasing strength by the process of strain hardening, adding of alloying elements, heat treatment process. In that process, resist the movement of atoms or dislocation, so that the strength increase. And next, when the resist the dislocation, reduce the plastic deformation of the elongation, so the material will be ductility will be lower, will be reduced ductility. Toughness and its relation. Toughness, the ability of the material to absorb energy before fracture. Before the fracture, the material how much the absorbed load to resist the strength, it is a toughness. In the stress and curve, they use it to measure the toughness of the given material. Toughness is dependent on the both strength and ductility. High strength, high ductility, high toughness. High strength plus low ductility, low moderate toughness. Low strength, high ductility, moderate toughness. Low strength plus low ductility, low toughness. Totally, the strength and ductility will be shows the toughness of the material. Young's modulus. Young's modulus and the strength. Young's modulus measure the toughness of the material. The Young's modulus stress strain curve will be denoted the slope in the yield point region. Resistant to the elastic. Young's modulus independent of the strength. Heat treatment, alloying of adding of alloying elements, cold working increases strength, but Young's modulus remains near constant. For example, mild steel and high strength steel have almost same Young's modulus, but different strength. But Young's modulus is constant. When the strength will be increased, but the Young's modulus is constant. Effect of work hardening. The work hardening is the increasing in the strength and hardness of the material due to the plastic deformation. Work hardening is also called as cold working. Cold working is one of the processes of heat treatment by strengthening the material. In the cold working process, is strength and hardness of the material will be increased due to the deformation of the material. Mechanisms of the work hardening process. Plastic deformation increase the dislocation density, resist the dislocation moment. Dislocation interact and block each other. Reduce the plastic deformation by the mechanism so that only material becomes the strength and hardened because of the movement of the dislocations. The material becomes stronger and harder. The effect of mechanical property. When the work hardening process, yield strength, ultimate strength, hardness will be increased, but ductility, toughness will be decreased by the specific process in the work hardening process. Conclusion. Tensile property are interconnected because the properties are strengthened, hardened, so that they are interconnected. Yield strength determines a designing limit. The yield strength are increased by the plastic deformation. UTS maximum capacity for before the loading of the material. Strength and ductility have increased the relationship because strength will be increased, ductility will be decreased. Toughness depends on the strength and the ductility. Toughness is depends only on the strength and ductility. When the ductility and will change, the toughness also change. Young's modulus is independent of the strength. Thank you.